Water is an essential part of life, which is found in all plants and animals. However, water is not always friendly to humans. In some situations, excess water breeds bacteria, corrupts goods, and damages useful materials. This can result in many problems, such as damp clothes and cigarettes, as well as an extremely humid environment. Therefore, sometimes we have to get rid of the extra water in such materials, through the process of dehydration or drying. Drying is a process that requires a large amount of energy to convert water from its liquid state into gaseous state, before it is finally released from the material. Needless to say, it is not very energy efficient. If you consider the total energy consumed from drying by the sun and air, this amount of energy will be close to half of our total energy consumption. Hence, it is very important for us to explore energy-saving technology for the purpose of drying. The following factors determine the speed of the drying process: surrounding temperature, air speed, relative humidity, surface area and characteristics of the material. If both the surface area and characteristics of the material are fixed, the only way to speed up the drying process is to either increase the temperature, increase the air speed, or reduce the relative humidity. When comparing the effects on the overall process of drying, air speed is more important than temperature, while relative humidity is more important than both. For example, if you leave wet clothes outside on a cold but dry winter day, they can finish drying within several hours. However, if you did the same thing on a warm and humid spring day, they will still be damp even after several days. Therefore, the best way to speed up the drying process is first to reduce the relative humidity in the air, then to increase the air speed, and finally to raise the temperature. While it is very easy to increase the air temperature, it is very difficult to reduce the relative humidity. In our mind, heating is a synonym for drying. Many drying machines are simply heating machines. The only difference among these heating machines is the energy source they use, such as coal, gas, wood, electricity and solar power. Many traditional drying machines use open-loop drying. This so-called open-loop drying refers to the process that exposes the material to the air, uses heat to vaporize water, and finally releases the vapor into the air. Generally speaking, except for drying by sun and air, all other open-loop drying methods require the building of a drying house as well as the consumption of many precious resources like coal, gas, wood, and electricity. The procedure is as follows. First, cold air is heated manually, and then used to warm up the material. After the water inside the material is vaporized, steam and hot air are both discharged from the discharge outlet into the air. This traditional drying method has the following disadvantages. First, most of the discharged is hot air and only some of it is steam. Both are precious energies but are wasted in this process. Therefore, this traditional drying method means a huge loss of energy, low efficiency and high energy cost. Second, it costs a large amount of energy to warm up cold air. This energy usage is even greater at lower temperatures and higher humidities. Due to a higher humidity in the drying house, it requires a higher temperature to achieve the same drying effect. However, a high temperature may cause damage to the quality of the material, especially for agricultural produce and aquatic products. Third, in order to maintain the temperature in the drying house, it is necessary to reduce the amount of air intake. This causes greater humidity, which in turn will slow down the drying process. Moreover, it is more difficult for the air to reach the whole drying house and achieve uniform drying effects. Fourth, in the beginning stage of drying, there is a film of water on the surface of the material that can easily cause mold to grow, especially if the surface area is large. The drying house becomes filled with moisture, and is often more humid in the upper half than the lower half. When the moisture in the upper half reaches the top of the drying house, it becomes water and drips back to the material closer to the top. This makes drying difficult and uneven, causing the material to easily deteriorate. Fifth, the active ingredients of some materials might get vaporized during the drying process, which lowers their quality. Sixth, when the cold air is brought in, it is inevitable for the machine to bring some other irritants like dust and mosquitoes into the material. Because of this, it is impossible to maintain a very sanitary condition. 7th. In order to achieve more uniform drying, workers are required to flip over the material. This practice increases labor costs and might cause damage to the appearance of the material. Drying is necessary anywhere, but it is especially useful for fields such as planting, farming, hotel management, and wood industry, all of which have infinitely broad markets. However, traditional drying technologies are lower in quality, and thus, cannot guarantee a good drying effect. Every year, 20% of agricultural products were lost due to poor drying. Currently, there is a great and urgent demand for more advanced energy-saving drying technology and equipment. At the present, the most advanced energy-saving drying technology is heat pump drying, which is divided into open-loop and closed-loop drying. The open-loop heat pump drying method has the same drying concept as the open-loop drying method, with only one exception: the heating structure is replaced with the heat pump, which saves 1 to 2 times more electricity than the simple electricity heating machines. The heat pump dryer is composed of an external structure and an internal structure. The external structure takes in energy from the air and sends it into the drying house through the internal structure. Open-loop heat pump drying also has similar problems as the traditional open-loop drying method. In addition, it may not achieve normal working conditions when the temperature of the environment reaches below 5 degrees Celsius. IKE has strived for many years to conquer all of the problems mentioned above. Finally, we have developed more advanced closed-loop aerofaction heat pump drying technology that offer a better drying quality and effect, and more significant power saving. At the same time, we have acquired certification and approval from both the Chinese Ministry of Agriculture and the Department of Agriculture of Hainan Province.
你消耗一度电可以把水付出的是3.5公斤至7斤水。
The IKE closed-loop aerofaction heat pump dryer is built into the sealed and heat-preserved drying house, from whose bottom the air is released and is returned to the upper part. The air then runs through the cold chips at 5 degrees Celsius to get cooler. The moisture in the air will be condensed into drops of water and collected by a dish below and discharged from the house through a water pipe. After dehydration, the air will run through the hot chips of 90 degrees Celsius, turn to dry and hot air of 60 degrees Celsius, and penetrate through the material, heating it up. This will release water from the material, which evaporates into the humid hot air and then is taken back into the dryer again. Eventually, the steam will be condensed onto the cold chips at 5 degrees Celsius and then discharged out of the drying house. The whole process will begin again, and will repeat until the material is thoroughly dried. In the above process, heat energy is circulated within the drying house, taken in by cold chips and released out from hot chips without any loss of heat. Therefore, it is highly efficient and completely immune from the impact of external temperature and humidity. The unique and creative design of the IKE closed-loop aerofaction heat pump dryer has completely solved all of the problems associated with the traditional open-loop dryers. In addition, it also features the following distinct advantages. First, 100% in-house energy recycled, high efficiency and low energy costs. For instance, 1 kilowatt-hour of electricity can dehydrate over 3 kilograms of water, and can easily dry 5 to 10 kilograms worth of agricultural products. Second, the sealed closed loop offers protection from the effects of outside temperature and humidity, so that the dryer can operate in any season and location with the same product efficiency and energy saving. Third, thanks to the aerofaction drying technology, the dryer doesn't depend on the surrounding temperature and humidity. It can achieve fast and good drying effect even in low temperature. The drying temperature inside the drying house could be set at anyone below 75 degrees Celsius and the drying humidity could be set at anyone between 10% and 99%. This will help achieve constant temperature and humidity drying and keep drying quality as good as possible. Fourth, completely sealed drying house allows airflow to be controlled at will so that there will be no dead spot without blowing air and the drying is guaranteed to be even. Fifth, extremely dry house and strong airflow inside the house make it impossible for a water film to form on the surface of the material. Even large products like betel nuts and sea fish will never get moldy and can be dried ideally. Sixth, active ingredients will never be lost in the drying process so that the quality and grade of the product are guaranteed to maintain, especially for herbs and flower tea. Seventh, outdoor irritants can never get in the drying house, helping it to maintain the highest sanitary condition. Eighth, strong airflow convection guarantees even drying. No manual flipping is needed. Ninth, all-in-one design makes installation extremely easy. 10th, programmable operation system achieves artificial intelligence control and demands no human on duty. With the advanced technology and superior quality, IKE's closed-loop aerofaction heat pump dryer has become the best choice of our clients.